Hi guys, welcome to this, another video for our linear equations part of this course. My name's Darren Maffs and it's really good to see you. Now obviously in a previous lesson we were looking at very much the idea of a relationship and an equation and what it looks like, and we came up with the idea that, you know, if we had graphs in the form of 2x minus 1, we could create a table of values, plot this thing by doing all these little kisses, join them all together with a straight line or a ruler, and ka-ching, thank you very much, there is my straight line. Awesome. Seems a little time consuming, don't you think? Well, absolutely it is, and there are other ways of doing it outside of using your CAS, which I also showed you in the previous video. Now, if you haven't already done so, can you do me a favor and subscribe to my YouTube channel? Never going to be rich, never going to be famous, but it just lets me know you're watching, and it saves me from sitting here in a room going slowly mad thinking that I'm only talking to myself while everyone else is watching videos of cats. There's also maffsguru.com, where all these videos, and it's totally free to sign up, where all these videos are by textbook, they've got downloadable notes, they've got time codes, there's going to be exam questions, and so much more. So head over there if you can, at maffsguru.com. Now, as I said in the previous lesson, we had both something called the gradient-intercept form, that's this form here that we've given by y equals mx plus c, and there was the intercept form, which was something like 3x plus 2y equals 6. Now, at this moment in time, we're not going to be dealing with those particular examples. They were useful for solving simultaneous equations by elimination substitution. Haven't seen that video? It's also on maffsguru.com. Head over there and watch. Oh, by the way, let your mates know. That'd be good. So we're going to look at what this y equals mx plus c form is. You probably remember, we've done it in year 9, probably done, but let's have a look at what the letters mean. Now, lots of people get really confused because they don't really understand why we have the y and the x in it. And believe it or not, it's so ridiculously silly, it's unbelievable. It is because in most cases, we label our axes x and y. Nothing more, nothing less. If my axes were labeled, say, a and b, then our equation would be a equals mb plus c. This a and that b is nothing more. So this first letter and that third letter are nothing more than what the labels are on my axes. And that's really important for later on, because when we start messing with your heads and we start changing this, thanks Barry, then ultimately we won't get tricked. So those letters stand for the axes labels, nothing more. But now let's look at the other two. We got this M and this C. And wouldn't it be lovely if we actually made sensible choices of letters, but Barry trying to confuse us. He's like, oh, what letter can we use? What letter can we use that'll really confuse the kids? M. I have an idea. Let's call M the gradient. Gradient doesn't even have an M in it. All right, but then obviously we have the intercept. At least that's got C in it. Now, what we're going to turn around and be very careful is that this value here is the y axis intercept, the vertical axis intercept. It crosses there. Now, again, be very careful. If we look at lines, generally speaking, they'll cross both axes. They'll cross here and they'll cross here. And sadly, a lot of people who don't really know what they're doing will give this value that I put a box around, and sadly, that's always going to be the wrong one. It is this vertical axis here, and where the line crosses through it, that's the coordinate position you want. And generally speaking, it is always 0, and some sort of number. Now again, at the end of my last video, we looked at the CAS and a table of results. That's going to become really important later on. The gradient of the line is what we're going to deal with this lesson, finding the gradient. And what on earth is the gradient? Well, basically, I think of it as a measure of slopiness. I used to ride a bike, don't anymore, because the concept of hills just depresses me. I don't want to go up a hill. I don't care if it's a steep hill, a narrow hill, or even just a slight bump. Not interested, too much like hard work, rather take my car. But what we've got here is a number of equations, 4 different equations. And if you want to know how I created this, there's a brilliant website called desmos.com where you can draw graphs and all sorts of stuff, and it's absolutely free to use. Just log on, desmos.com. So you'll notice that I've got green, blue, try that one again. Green, red, blue, green, and purple, and each of those is an equation. All right, y equals 3x plus 1, y equals 2x plus 1. And what we notice is that we've got 4 lines here. A red line, well, that's obviously the y equals 3x plus 1. We've got that line there, which I'm going to tell you is the y equals 2x plus 1. we have this one here, which I'm going to tell you is y equals 1, and the green line, which is y is equal to minus x plus 1. Now, if we look at them, two of them seem to be going up, one of them seems to be horizontal, and one of them seems to be going down. And if we notice, these here are the ones that are actually sloping up. This is the one that seems to be sloping down, and that one there seems to be just going horizontally. Why? What is it about that that makes life interesting? Or, more importantly, can you see why or which one of those numbers is helping us decide which graph it is? Okay, so points of learning at this moment in time is graphs can either be positive, they have a positive gradient, that is slopes up. They can have a negative gradient, they slope down. They can have a horizontal gradient, which is 0. So if its line is perfectly flat, it's 0. And if it's vertical, it's like hell to the no. Are you kidding me? Not even vaguely thinking about it. That's 0. That's an infinity. That's like undefined, whatever else. We'll come to that later. All right. So when I was at school, funny enough, we called vertical lines and we said they had an infinite gradient. Nowadays we call it undefined. I don't know why. So positive gradients slope up. Negative gradients slope down. Horizontal lines have a 0 gradient. You're going to say that's not even vaguely horizontal. I'm trying, okay? And so we can see here that that has a positive gradient, that has a positive gradient, that has a negative gradient, and that has a gradient of 0. So identifying these things is really, really important. But now let's have a look and see what part of that equation actually made the line slopey, or what changed. So now 3 different graphs. One is 3x plus 1, one is 3x plus 2, and one is just 3x. And what do you notice? That basically all of these lines here are parallel. They are never going to meet. They're going to go to infinity and beyond and never ever going to meet. What is the only thing they have in common? And in fact, you'll notice it is the 3. So all of those have that 3 in common. They all seemingly have the same slope, so it makes sense then that that value there, that m, is equal to the slope of my line. And because they are all the same, they are going to be parallel. Now again, what do you notice about the values? They're all plus 3. Now again, we don't write the plus in front of the 3. If it's positive, we don't write the plus. So that's a positive gradient, that's a positive gradient, and that's a positive gradient. But I suppose the question is, if I was given a line and I wanted to find the gradient, as I have been here, I've been given a line, how would I find the gradient of the line? Well, we need some measure of slopiness. And it turns out we do. We can say the gradient is equal to the rise of the line divided by the run. What the flipping heck is rise and run? Well, rise is how high it goes, and run is how across it goes. Now, to be able to do this, all you have to do is choose 2 points on the line. Now, I'm going to give you a bit of a hint here. When you choose 2 points, you tend to choose them on parts of the graph where they cross each other. And what I'm saying is, do you notice there that crosses through? And you notice there that crosses through. It's got a nice cross through 1 and 2. So it actually fits on some nice values on my x-axis and my y-axis. Likewise, that one fits on 2 and 4. All right, so why would I not necessarily choose this value there? Well, it doesn't necessarily make it helpful. You're going to say, well, did I have to choose those values? Believe it or not, no. Choose any values. But come back to that in a moment. Now, all I need to do now is draw a triangle by going across and down. Now, what do you notice? I'm going across until I'm level with this point, and then I go up until I meet the point. So like a game of Snake, if you guys ever remember Snake. Yes, so you go across and up. And believe it or not, this here now is my rise, and this here is my run. And you can say, well, what does that mean? Well, actually, I just count squares now. Or in this situation, because that's going from, what value is that? 2 to 4, because it's going from the 2 to 4, I know that that has a rise of 2 units. It's going up 2 units. How horizontal is it going across? Well, it's going from 1 to 2, and so in which case it has 1 unit. So therefore my gradient is given by rise, which is 2, divided by run, which is 1, and lo and behold, my gradient is 2. So in my equation of this line, whatever it's going to be, I now know that m is equal to 2. And remember, gradient and m exactly the same thing. What are we going to do with this one here? All right, same, but a bit of a trick. So first things first, we're going to try and find a point that we can use. Well, that one there seems to be a nice point to use because, again, it's going through 1 and -3. That's lovely. Is there another one that crosses through one of those? Oh, hold on a moment. Oh, hold on. Yeah, look, 0. Oh, we like it when it goes through 0. It's a bit weird. I'm sorry, I sounded like I was talking to my daughter then. That was very peculiar. So what are we going to do now? Well, those are the 2 points I've chosen. I'm now going to go all down. Hold on a moment. This is down till I'm level, and then across until I meet my line. So this is now going to be my rise, and this is going to be my run. So how many squares down have I gone? I've gone 1, 2, 3. So I'm starting at 0 and I'm going to -3. So that is, well, we can either write 3 or we can write -3. Now, I tell you what, I normally write 3. I'm just interested in the number of squares. How many run has it gone? Well, it's gone from 0 to 1, so it's got a run of 1. So my gradient in this case must be rise, which is 3, divided by run, which is 1. But do you notice the problem? What do you notice about this line? Is it sloping up or is it sloping down? It's actually sloping down. So we know that the gradient of this must be negative, and so I have to put a minus sign in there. So -3 divided by 1 gives me my gradient, or my m value, as -3. So lines that slope down are there as a bit of a trick. Let's see, what can we do? Another one here. Let's choose my points. So there's a point there, and there's a point there. They seem to be going through nice, easy stuff for me. So we're going to draw my triangle. We're going to go down until we're level, and then we're going to go across until we meet. There is my rise, and there is my run. Is my line up or down? It's sloping up, so it's going to be a positive gradient. So my rise is going from 2 to 4, so that's a rise of 2, and again a run of 1. My goodness, you could have chosen easier or harder questions, maths guru. So in which case, again, my gradient is 2. Now there is another way of doing it, and again, maths tries to trick you. And we come up with this strange looking formula that, believe it or not, you already know. So gradient here is given by y2 minus y1 over x2 minus x1. And you're going to go, what? Well, basically, let's look back at the 2 points I looked at earlier. Yeah? We now know that each of those points have a coordinate. This one here is 1, 4, and this one here is 0, 2. Happy so far? But we also know that each of those coordinates has a letter. So this is an x value, and that is a y value, and that is an x value, and that is a y value. Now, because we have 2 coordinates, we actually try and keep the difference, because we can't have x and y for both of them. So we generally call this one x2, y2, and x1, y1. Hold on a minute. Look what you got here, y2 minus y1. Oh my goodness, I've got a y2 minus y1. Well, because y stands for up, we've got one up coordinate, subtract another up coordinate. Oh my goodness, this is just another way of saying rise. And again, if we look at the difference between my x coordinates, I'm just going to look at my run. So let's just check that. What's the difference between 1 and 0? 1. And what's the difference between 4 and 2? It was 2. And if you remember from the previous example, oops, let's write that, gradient was 2 divided by 1, which was 2, which is exactly what we got. So sometimes we don't even have to have the graph now. If they give us the coordinates, we can actually do this funky stuff straight away. Okay, so here we go. We've got an example. Find the slope of the line that passed through the points 1, 7, and 4, 2. Right, now whenever I have these, you'll notice that what I'm doing out for you is exactly the same. So I tend to do x1, y1, x2, y2. And I know that my gradient is y2 minus y1 on x2 minus x1. So we're now going to substitute in the values. What's the value of y2? It's 2. I'm going to subtract from that y1, which is 7, divided by x2, which is 4. And I'm going to subtract x1, which is 1. 2 minus 7 is -5. 4 minus 1 is 3. and ka-ching, there is my right answer. And I can also get my CAS calculator to do this for me. Oh my goodness, could it be any easier? Now, there is a final note, all right? You can find the gradient anywhere along that line, and I'm going to show you. There is one point I chose, and there is another point I chose, but I could have chosen that point there as well. I could have chosen any of those points, and let's just check. If I now go down from here to here, what is my rise? It is 2. What is my run? It is 1. Well, let's imagine actually I did the same thing here. And there is my triangle. What is my rise? It's 2, actually going between just this point and that point there. And what is my run? It is 1. So what do we notice? Between 2 different points, 2 and 1. But we can even go better, and we can say, well, let's go from that top one across. So what do we notice? My rise now would be 4, and my run would be 2. So let's just check. With one of them, we had gradient was equal to 2 divided by 1, which was 2. The other one, we had gradient was 2 divided by 1, which was also 2. And the gradient of that big red triangle was 4 divided by 2, which is 2. Ka-ching. We've just shown that so long as we choose sensible points, and 2 of them on that line, the gradient is going to be the same all the way along that line. Ka-ching. But that almost sort of makes sense, doesn't it? You know, the gradient along a straight line would be the same because it's a measure of slopiness. It's not like as we go along that line, the slope changes, because that would be a bit weird. And ladies and gentlemen, I'm done. Thank you very much for watching. If you can, there's 2 more minutes of this video to watch. Please subscribe, please like my video, and head to Maffs Guru if you can to help me out. Otherwise, hopefully I'll see you in another video. Take care, guys. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is maffsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.